What happens is these two guys are inverse properties of one another. To undo it, if you substituted one for the other, they wind up working. For example, see how they both have the y's. Well, here's what happens. If we take f of x and g of x, just like we've done before, and you take we'll label it this way. We'll say f of x is log base b of x. We'll say g of x is b to the x. Remember when we talked about inverses? If you substitute in one for the other, what should you always get both ways to show that they are inverses of each other? Do you remember? X, very good. You should get x. So if I take f of g of x, that means take the g of x equation, surround it with everything else. So I'm substituting it in for x, and I'm surrounding it with the rest. What happens here, and this is where I was getting at with that example you were talking about with number 33. When you have the same base, when it's the log base, and it's the same base of the value after it, those bases, for lack of better terms, cancel each other out. They undo it. This simplifies, this exponent falls. That's how that exponent is able to fall. Okay? So, like we had the example in number 33, where it was log base 4 of 4 to the negative 0.38. Since these two bases were identical, your answer became negative 0.38. That exponent just falls. So the trick lies that can you rewrite any log base to have that next integer as that same log base? So with 25, what was it? 35 is log base 1/5 of 25. Well, that would have been 1/5 to the negative 2, I believe. So that's the same thing as saying log base 1/5 of 1/5 to the negative 2. Now, these two bases, since those bases are the same, what happens to the exponent? It drops. Now, you looked at me all crazy, like more so than normal, because you're wondering, why do I know it's 1/5 to the negative 2? Am I right? Okay. Remember, a lot of times when you're switching from fraction to whole number, the easy thing to do is to raise it to a negative power by flipping them around. So if I'm thinking that 25 is 5 squared, what I can do is this. If I take 1/5, and if I put it to the negative 2, that means this fraction is unhappy. It means it's 1 to the negative 2, 5 to the negative 2, which means it's 5 squared over 1 squared. I'm using that. That negative exponent allows me to flip fractions without too much of a hassle. Does that seem a little bit clearer then? Mm-hmm. You're not buying it.
No, I completely understand that. I just don't understand, like, if you know it's negative 2, why do you need to cancel out with 1/5? Like, if you know the answer is negative 2, like, what's the point?
Well, it's just simplifying. That's all that. It's just simplifying. It's all it is. It's just simplifying.
Extra work. It's like, you know that 1/5 to the negative 2 is 25. So why do you need to, like, go on and
Because you want to keep it warm. That's why you keep the log in it. Okay. That's it. You know what? If you can simplify it, it's awesome. Great. I'm just taking the extra step. I'm just showing you. That's all. So I'm not going to yell at you. Nothing wrong with it. Here, we'll air 5 and not make it hurt. Ow! Hey, look at it this way. The rest of your day's going to be better after you get out of here, right?
You're gonna make her cry. What? You're gonna make her cry.
I'm not going to make her cry. I'm making her cry. I'm just having fun. I bought tickets to go see Pearl Jam. I don't care really much about it anymore today. I really don't. My day's over. We're getting there. No. All right, anyway. So, and we go the same way. I've had my tickets for Pearl Jam for the summer. Anyway, so we go the other way. We have if g of x was e to the x and f of x was log base b of x, if I want to do g of f of x, we start with the f of x equation, and I substitute that in for x here, so that log base becomes the exponent. And it's the same principle. Notice you have the same bases. You have a base raised to an exponent with the same base. The bases are the same, therefore they cancel each other out, and your answer is x. Yes, ma'am?
Why was the first
Because it's the base raised to an exponent. It's kind of like writing it like this: 3 to the log base 3 of x.
Oh.
Okay, it's just, it's so tough to write it with letters and try to show that there's,
Like log b to x
is an exponent. Yep. Yes, sir.
What happens to like log after you cancel out the b's?
They undo each other.
So like log is a part of the other b.
Exactly right. Okay. That's how these inverse properties work. That's how we're able to undo problems. That's how you're able to simplify things with pretty much relative ease by just using some of the properties. Let's see here. For example, I have 10 raised to the log of 2. If I have 10 raised to the log of 2, well, what's the log base that you don't see? 10. So what is your answer? 2. Your answer is 2. Are we okay with that?
No.
What happens here, when you don't have a base, it's implied that it's base 10. That's all it means.
Just because?
Just because. Log base 10 is the log base 10 is standard base.
So like if there was like 3 in front of it, it's still like a 10.
If it was 3 log of 2,
Yeah, it's still a 10 or
it would still be log base 10. You could not simplify that. Okay. You'll get there. Log base 3 of 9 to the x, which means I need to rewrite 9 as a base 3. How do you rewrite 9 as base 3? Just base 3. 9 is 3 to what power? Squared. So this is log base 3 of 3 squared times x. What's your answer? 2x. You're rewriting the bases to get identical bases. You want the identical base so that it simplifies. So the exponent falls. This is what's going to allow you to do a lot of algebra problems later on.
So what does log mean?
Logarithms are used for stuff like this. How do you solve for the exponent if you don't know what it is? You use the logarithm. That's what they came from. They're able to. They allow you to solve for an unknown value that is not integer based or fractional, for roots and whatnot, to solve equations. Okay. Bless you. Okay. Take a minute and do those 4. The logarithms, shifting gears. Log base 2 of 64 is? 6. Very good. Okay? So it's log base 2 of 2 to the 6th. 6. Log base 25 of 5. Negative 1/2. So it's log base 25. And you want to write this as, we do, because if you put that to the negative 1/2, what's that? No, because you have to rewrite this to get it to a base 25.
Can't use square.
So if you rewrite it,
Yeah, square it, then it's 0.
What's that?
Square.
Oh, because if you square it, but that's not getting you to the same base here. Okay?
I got it.
Well, we want to relate this to the base. So I want to create this to an exponent to make that base the same.
Just have it.
Just
go.
Oh, right.
I'm not gonna ask you.
Log base 6 of 1. Remember that rule?
0.
0.
Oh.
That was one of our properties we talked about yesterday. Anything with log base b of 1 is 0. Okay? What was the other one? Yes, ma'am. Excuse me. When you go back in here, we need to create, oops. We need to have this. Okay. We need to get those to work themselves out. So in order to create that base, I need to figure out a way to turn a 5 into a 25 by just rewriting a base 25. Okay. This is the same then. Oops, move this up so you can see it. I thought you said negative.
No, you
said- Did I say
negative.
negative?
You said negative one.
Jeez, I'm sorry. No wonder.
I was like, what the heck?
No wonder I was wondering why you said. I thought you said it.
No,
Then I
you
said it.
You said it the whole time. You said negative one.
Negative.
I swear I thought you said this. You said negative. Like no, you gotta.
You even wrote negative one.
I did.
Yeah.
You said like 5. It's like, you said 5 now.
That's why I got so confused.
Welcome to my world. Back to this. Anyway, I want to write it as the same base. Life child, help me. Thank you.
You got it. There you go.
I'm sorry.
Is that the thought?
Apparently. New flavor. Caramel butterscotch. Delicious.
What?
I'm just confused. I don't
Heard
understand.
that before.
Never a dull moment third hour, I tell you.
You
12th
already
hour, it's like all normal. All right? I get all the messes ups out of the way here.
Thanks, my parents told me I was next too.
So log base, excuse me, 10 to the log base something of 4. What's the answer? 4. Now, real fast, on number 11, that style is the one that'll sneak up on you and you're going to not remember it. That goes with those two properties I threw on the board real quick. Anytime you have log base whatever of 1, your answer is going to be 0. Because that means that its base to the 0 has to equal 1. Okay? Same thing when it's log base b of b. When your bases are the same right off the bat, it's going to have to equal 1. All right? Those are those properties we talked about yesterday. Let's see what's the other one we had in here. Natural log. Your common log, like we talked about, is your base 10. We switch log bases around a lot of times. So this is just your normal log. Log base 10 of x is just log of x. What happens now is that we have natural log, ln. I know you guys have all seen that button on your calculator. You have the ln button. You might have used it, I bet, in chem. No? I know with E you use E sometimes with in chem, but I think you will use it in that too. So my wife has asked me about what that was also. So what happens is, if you ever have, and this is going to show up kind of a lot with us, whenever you have log base E of x, it is the natural log of x. Bless you.
Is the exponent or is it just?
Just straight across, yeah. These are all on the same line. This is the subscript.
What do you call that, subscript?
Yeah. So it's log base E. Whenever you have log base E, that means it's a natural log. Now, on your calculator, you have that LN button. That's what log base E stands for. You will see some LN is right
Right below log.
right below log. Convenient. What'll happen with natural log, and we'll probably spend a little bit more time on this when we start working with the actual properties of solving equations. Natural log is just log base E. They mean the same thing. It's just another way of writing it. That's all that is. Okay. Log base E is natural log. Right. And I'll show you how we're going to do this here in a second. That's graphing. Let me pull up the problem. I already had it open. Let's see what else. No, I don't want to do this one yet. I want to do the, where's my inverse sheet for that fast? Sequence. Let me pull the, I want to do an inverse of this before you guys, before I show you the natural log. So let's write an inverse out of a logarithm. I want to do the one.
I should have drawn this class. I said I should have drawn this class.
Let's do this one. Let's do the inverse. Let's go with the inverse of log base 3 of x. Now, when you have inverse of log base, do you remember what the rule was? It's written on the board.
That.
E to the x equals 1. So the inverse of this is remember, you have your log base b of x, log base b of y is x, and b to the x. Those were the inverses of one another. Okay? Those were the inverses of one another. So what's the inverse then?
3 x something.
Okay. Yeah. Just use some property straight through. Now, the weird one comes in with the natural log, and that's what I wanted to show you before I get the ones with h's and k's here. So we want to do the inverse of the natural log. I want to do the one here. It's x plus 1. Okay. Now, when you have the natural log one written out, remember how we did the inverses before? We flip-flop x and y and rewrite and resolve. So do the same setup. Now's the trick. Remember when we first found inverses? When you have y equals 2x plus 1, I want to find the inverse of it. I would say x equals 2y plus 1, I'd resolve, so x minus 1 divided by 2 is y. Now, we do the same thing, but we have to figure out a way to undo a natural log. And this is the trick about some of the properties. Natural log is log base what? E. So what I'm going to do here is, eventually you won't have to write this step, but I'm going to write this out. X equals log base e of y plus 1. I need to undo a log base e. So in order to undo a log, you have to use one of our properties. Well, one of the properties that we had was log base b, or b to the log base b of x. What would that equal? X. So what base would I have to drop in front of that log to make the stuff in parentheses fall? E. What we're doing here is a term, I don't think it's the right term. I'm going to call it exponentiating it. Exponentiating, a little stuffy. By doing that, I'm doing this. I'm raising it, I'm turning it into an exponent. And I do that on both sides of the equation. So right now then I have e to the x equals e to the log base e of y plus 1. So this then, very good. So I get e to the x equals y plus 1. And now to get y by itself, what do you do? Subtract 1. So it's e to the x minus 1 is y. The e just stays, yes. What you're doing here is a trick that we're going to get into when we're solving equations. By getting rid of a logarithm to get rid of something that's in parentheses, you exponentiate it. You turn that logarithm into a base to utilize one of these properties. That's how we get rid of one of these properties. This happens a lot. We're going to put another one next to it so it's somewhat similar. So let's see, it's y equals 2 natural log of x minus 4. I want to do the inverse. What's up?
Is that 21?
2 natural log. All right, how about this? We'll get the scalar out of the way. We won't do a scalar yet. All right, so we don't mess with it. Yes, I don't think we have scalars in this first unit. I think it comes in the next one. First step, just like we did before, flip-flop x and y. Natural log is what log base? Log base e. To get rid of the stuff in parentheses, we e it or exponentiate it.
How do you spell
Exponentiate. You're asking a math teacher to spell something. So what do you get then?
4. X to the e plus 4.
E to the x equals y plus, or excuse me, y minus 4. And there you are. We are all out of them. Mr. Fontana is going to order more.
Wait, all what?
Tissues. Sorry. I know I've used one too. I'm all clogged up.
Bringing in for extra credit.
No, because not everybody can. What if people can't get them? You know what I mean?
Oh, they can get it.
I know, but still, I don't like it.
Yeah. If the whole class brings in a certain amount, everyone gets on with it.
Everyone bring in an individual tissue and one with them.
Oh, hey, by the way, your quizzes, you guys did really well.
Are you sure?
I put them in last night.
Can I check
You guys did really, really well. Yeah, there was really nothing. The only goofiness that there was like maybe 1 or 2 questions that people goofed up on because they just pressed the wrong buttons. But other than that, like I said, that first unit, these first 3 sections are breeze. You guys did fine. So let's do this then. I don't want to graph yet. So same section. Let's just add to what you have. Let's just do numbers 48 through 64 all. Yeah, so it's the same stuff. So same page, so whatever that was, page 490. This is still the same section, 8.4. Just do 48, what did I say, 62? 64. Okay. you'll see right off the bat, a lot of them are use the inverses. For example, number 48 says 5 to the log base 5 of x. What is the answer? X. And the ones that'll take a minute longer are going to be your inverses. But if it's y equals log base 9 of x, what's the inverse? 9 to the x equals y. Yeah. Okay.
Barely.
We'll go from there.
I need some extra credit.
Did you get up the calculator part?
Me? 90.
Okay, logarithm.
I got a D.
I got a 75 and a...
Graphing here a little
I
goofy.
got a D on the calculator part.
I got 100% on both.
He's not kidding either though.